So a quick recap of ionic precipitation for insoluble salts before we move on. And for example, we need to prepare barium sulfate in lab. We need to prepare crystals of barium sulfate. What we'll do is we'll take a solution which has barium ions, for example, barium chloride. It has to be soluble in water, and we'll take another solution which is having sulfate ions, and in this case we took magnesium sulfate. We'll mix these two solutions together, and we'll get barium sulfate, which is an insoluble salt. Barium ions from barium chloride and sulfate ions from barium sulfate will react together to give us barium sulfate, which is a white precipitate, or which is a white solid which is insoluble in water. When these precipitates are formed, we'll filter them off, and after this residue is obtained, we'll just dry it, we'll rinse the PPT so that we can impurities are removed, and then we'll dry it to evaporate water. Alright, we can dry them in oven, or we can dry them with filter paper, whatever we want. So this is ionic precipitation for insoluble salts. Let's now move on to soluble salts. How can we obtain soluble salts? What are the different methods to obtain soluble salts? So the first method is when we use metal and when we react a metal with an acid. Alright, metal plus acid to give salt and hydrogen gas. That is the first method that we're going to study. So metal plus acid, it reacts to form a salt that we need and a hydrogen gas. So in the first case, the salt that we need to prepare is zinc sulfate. So you can guess that we must need zinc as a starting material, and we need an acid which has sulfate ions. And what is that acid? That acid is sulfuric acid. So we need to react zinc plus sulfuric acid, and it will give us zinc sulfate plus hydrogen gas. So zinc sulfate can be made by reacting dilute sulfuric acid with zinc, as you can see over here. Zinc is solid, will add solid zinc into the sulfuric acid, and it will give us zinc sulfate, which is obviously aqueous because it is a soluble salt, and hydrogen gas will be released. So here are the steps on how to carry out this reaction. Add zinc and sulfuric acid, and remember, you must add excess zinc. Soon you will realize why excess zinc must be added. What if you add a little zinc? You will have some trouble, and you will realize it very soon. So you need to add excess zinc in sulfuric acid. Add excess zinc to acid in a beaker. It starts to dissolve. Obviously, when zinc sulfate is being formed and hydrogen gas is being released, you will see zinc losing or shrinking in size. Zinc will start to dissolve in that acid. Alright, you will see bubbles being produced, and these bubbles will be of hydrogen gas because hydrogen gas will be released. Bubbling will stop when all acid is used up. So because you have excess zinc, the limiting reagent is sulfuric acid. Sulfuric acid is in the limiting quantity. Limiting reagent is sulfuric acid. So which means zinc is in excess. When all sulfuric acid has been used up, the reaction will stop. And obviously you'll have some zinc as residue because not all zinc will be used up. Zinc is in excess. Hydrogen or sulfuric acid will be used up. Sulfuric acid will finish, and then the reaction will stop. Alright, so this unreacted zinc, or the zinc that was in excess, will filter it off. Excess zinc is removed by filtration. Filtrate will be aqueous solution of zinc sulfate. Now we know that whatever is left behind, it is zinc sulfate solution, and there are no traces of sulfuric acid. Zinc was in excess, and all sulfuric acid was used up. So that is why we are sure that the filtrate that we have, it is purely zinc sulfate. Alright, so yeah, it is an aqueous solution of zinc sulfate which we needed. If zinc was not in excess, and if there was if all the zinc uh, if all the sulfuric acid was not used up, then we would surely obtain some of sulfuric acid over here. But we do not get that. Why? Because zinc was in excess, and we are sure that all the sulfuric acid that was present, it has been used up by the zinc. That is why we have some unreacted zinc over here. If there were some traces of sulfuric acid left, then they would have reacted with this zinc. So that is why adding excess zinc is important. And now that we have only a solution of zinc sulfate, we have a solution for zinc sulfate only, so we can heat the solution of zinc sulfate to evaporate water, and what will be left behind will be zinc sulfate crystals only. Alright, zinc sulfate aqueous is over here. We heat it to evaporate water, and when water is removed, zinc sulfate will be left behind. Heat the solution to evaporate some water. Do not heat to dryness because water is needed for crystallization. We need zinc sulfate is a hydrated salt, and we need to have some water of crystallization for the crystals to form. Otherwise, it will just be a powder. Crystal formation requires some water, and it is necessary that you do not heat the solution to dryness. You leave some water for the formation of crystals. Alright, when saturated solution is obtained, let it cool down. Crystals of zinc sulfate will appear. When enough of water is evaporated, yeah, just leave it, just turn off the heat and leave it at room temperature so that slow cooling can take place, and which is beneficial for crystals formation. Alright, so this is how you obtain salt by reacting metal and acid. The same I want to repeat by another example, and here you'll be able to see some visuals as well. Alright, so this is an acid in this beaker, and you're adding metal or metal oxide or metal carbonate in it. They all have the same process. Whether you want to react metal with an acid, metal oxide with an acid, or metal carbonate with an acid, what you'll do is you'll add excess of these things in an acid, and you'll a solution will be formed. A solution of required salt will be formed, and because you have added these in excess, so you will filter them off, and excess will be removed, and you'll be left with solution of the required salt only. Now when you have the solution, you can simply evaporate the solution by heating, and when you'll heat the solution, a saturated solution will be formed, and you'll leave it to cool down, and when it cools down, the crystals will start to appear. I hope it is making sense. And when those crystals are formed, you can wash them with water, or you can then separate, or you can then dry them with the help of filter paper. Alright, yes, so that is how you obtain salt by the reacting acids with metals, and we'll soon see how metal oxides and metal carbonates are used to form acids in the next video.